And with that, it is my absolute pleasure to introduce a first speaker whose topic is very relevant to my interests as a demo scener. We have Nick Boucart presenting for us this morning. He's going to talk about Nerdkunst, about the beauty of generative art. In his spare time, he teaches kids how to program using Scratch and processing, and he's always looking for good and approachable and easy ways to introduce people to the wonders of programming. And one such ways is the perfect intersection of programming, mathematics, and beauty. And that's what generative art is about. So please give a warm welcome to Nick.
Thanks for the intro. Happy to be here. Thanks for showing up. Imagine you write a little program that randomly prints a backslash or a forward slash. How boring could that be? Well, actually, I don't think it's really boring. You get these kind of things. And the funny thing is, these kind of things, this is a unique piece of work, because every backslash or every forward slash is generated at random. So you will see this image only once, probably, or you have to do it like a gazillion times and then let luck generate the same image. This is a famous one-liner. In the early 80s, there was in the Commodore 64 community and Atari communities, there was like there was like a running thing where people tried to write one-liners that in one line did something special. This was one of them. There's an open source book written about the 10 print one-liner. So this is basically it, and it generates nice pictures. Nice, you can debate about that, but it generates something interesting that you wouldn't expect by just having a bit of code. I want to give this talk about generative art because I think I'm not an artist by any means. I'm more, if anything, I'm more an educator than an artist. I think it's a very nice intersection, like mentioned earlier, between, on one hand, programming, which is something probably most of you like and love, about art, and about mathematics and science. I studied physics myself, so I eat numbers and formulas for breakfast. I used to eat that for breakfast. I find this a very nice intersection to have these things together. Wikipedia says that generative art is something that is where an artist programs a system and the system then generates pieces, artwork pieces, and typically there is a bit of randomness in it, not always. That's the whole thing. It's not more and not less than that. Of course, I'm definitely not the first one trying these things out. Definitely not. Since there were computers, since the 60s, people have done stuff with computers to generate art. I'll honor a few of them. You have Vera Molnar. She's a Swiss-Hungarian artist, and she was one of the first in the 60s to make computer programs that then were sent to a plotter, and she made artworks like these things. I mean, this is not something you do by hand probably, but this is all generated, or something like this. Some are more interesting than others, and that depends even from person to person. Stuff like this. There's Harold Cohen. He was a British guy. He was the first to do something with artificial intelligence, way before it was called artificial intelligence, and he made these kind of things. And then there's, of course, Casey Rees, I don't exactly know how to pronounce it. He's the one who wrote together with a friend of his who wrote Processing, which is if I not recall, a Java library that allows you to express yourself in code and generate these pieces of work. These are some of his works. I mean, pretty interesting. This is, you see, on one hand, you see you see that there is mathematics behind it. You don't know which one, but it feels like something procedural, something science-like, and still it's very nice to look at, and that's why I really like these things. This fella, he made some real big, I don't know if it's too dark, don't see. He makes big installations where he uses technology like AI, like it's a bit of activism as well. All very nice, all very cool. Now, and of course, with ChatGPT and DALI and so on, everybody can be a generative artist today in the sense of you just prompt a system and then automatically something comes out of it, and sometimes it's nice, sometimes it's not nice, sometimes it even reflects what you want it to do, sometimes not. I'm not sure whether this is really generative AI or generative art. I'm still up to debate, but whatever. Because it's digital, because there's numerous ways to present your art. Initially, people just plotted their artworks, and then it was like a painting or a drawing, and then they hang it up. But you can, of course, build digital photo frames. You can have a Raspberry Pi where you put your scripts on and then have it rotate. You can interact with webcams. You can do all sorts of stuff. It can become quite elaborate, quite complex, quite quickly, and have lots of different forms of art. You can even and that's what I will be demonstrating later on. You can even live code, so that you interact with the code, you change the rules, and then of course other paintings, other drawings are generated on the fly, which is which is for me also a very nice way to see how changes in your algorithms, changes in your code reflect directly in real life or in the output, and gives you a very interactive REPL-like experience to program. For me, it's really, I'm a big believer in showing and not telling, in the sense that, code is one thing, and code can be very nice but if it does something, if it produces something, that's even nicer. So it allows you to really show what your work is all about. I use it with the kids in the Coder Dojo. I sometimes use it to really explore programming and algorithms in a very visual and very low threshold and low barrier of entry kind of way. I wish my teacher at the time, when he explained sines and cosines, had something visually and moving. I will show later on an example of that really shows how these things work. It makes it much more easy to grasp, right? It is somehow a combo of science and computer science and art. I mean, you need to know a bit about algorithms, or you get to know a bit about algorithms and work your way through it. But the end goal is not something that fixes your taxes or something, but really something visually pleasing. Or voila, it's educational, and I will show that later. It's just super fun to fiddle with parameters and to see how your artwork changes if you just change a color or the thickness of a line or something. It just brings it to life, and before you know it, you're 3 hours later, and you just had a lot of fun. For me, that really works. Some key concepts. You have, of course, the artist or the person making the rules. The rules are then the instructions you give to the computer to generate the art. There's typically some randomness involved. Repetition patterns, remember the forward slash things. And emergence, that means that, despite the fact that the rules are relatively simple, something pops up that generates emotion. Sometimes you like it a bit more. This is all pretty abstract, so let's try to make it a bit concrete. For example, if I change the size here, voila. If I change the size here and I run the thing again, you see it's a similar thing. And if you just run it again and again, it just generates using the same rules, but it generates something else. If you make it 10, for example, you get a similar thing but a lot denser. I mean, for some people this might be nicer or not. Why not make it a green background and a blue? I mean, I'm not an aesthetic guy. That's then So I'm more into the for me personally the left side is but let's make it again 20. Okay, now here I roll a dice on line, what is it, line 15. I roll a dice, and if it's below a random number between 0 and 1, if it's below a half, I put a backslash and otherwise a forward slash, or vice versa. But I could say, okay, what would happen then? Yeah, then you get something again along the same lines, but now it favors a bit more the forward slashes in this case, or the backward slashes if I would make it 9, for example. Yeah, I mean, you start playing with it. What would happen if I make a bit thicker lines? Then you get something like this, and maybe if I do it a bit smaller, what then? Then you get these kind of things. I don't know if that's really visible, but you see, before you know it, you're half an hour later, and you're experimenting and playing with stuff. And this is all based on that single one-liner that I showed you earlier. Again, it's not my invention, not at all, but it's it's fun. Some of the tools that you could use, that's processing. I don't know if processing is still used that much. There's a port in JavaScript, it's called P5JS, which is what I'm using here. It has more or less the same API, and since it runs in the browser, it means you just open up an editor. They have a nice editor online, and you just can start tinkering. Sonic Pi for music. There's people who do all sorts of crazy stuff, programming in Blender, which is a 3D environment, and then have all sorts of stuff. So the sky is the limit. This is processing. I personally like processing a lot. P5 a lot, because it is JavaScript. It's online. You have an editor. So if you are running a workshop with kids, they just need to open the browser. They just have to load one time that editor, and they can work. Nothing to install, nothing special. They have good documentation. There are on YouTube a gazillion tutorials online. I really encourage you to watch the Code Train videos. The guy is just super. He explains the mathematics behind it, but also the programming and how you build it up. Super cool. And since it's JavaScript, you can extend it with a lot of other things. I have a demo later where I use a JavaScript machine learning model that can recognize faces to interact with that and do something with that. Okay. In the next part of the presentation, which is probably the bulk of it, I will go through some basics of P5 if you have some time later this weekend to just get started on your own, and I'll show you some examples of things that can be done and with the code and with some tinkering. And in the end, I have a bit of music as well that I can show in Strudel. Okay. Some basics. This is like a minimal P5 sketch. You have a setup and a draw function. It's very similar to Arduino. Who knows Arduino a bit? There it's called setup and loop, I think, or something like that. Yeah. So the setup is typically run once, and the draw function is run in a continuous loop. And the minimal script is basically you create a canvas. The canvas is like an element that you can paint on. It's an HTML5 canvas element, and you give it a background or color, or you draw things on it. For example, here I draw a couple of shapes. I say next thing fill red, and I do a circle. These are the coordinates of the middle point, the radius. I can change that radius to 100, and you'll see that the circle becomes just a bit bigger. You can say stroke, which means it's the outside of the object. In this case, magenta, and I do a line. Or in this case, no fill means I don't want that object to be filled in, and I write a rectangle where the top left is in position 300 200, and it's 55 wide and 40 high. Okay, not too fancy. Not too. If I would comment out this line, it just fills out. It takes up the fill red that was a bit earlier in the script. Voila. And of course, if you change these coordinates, you can make it whatever you want. Plof, then it's there. plop, 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 and it works. Movement. For movement, you typically use the draw function. And what you typically then do in the draw function is you write the background, which means basically you repaint the whole canvas in one color, and then you, in this case, you write an ellipse, where the size of that ellipse, or it's a circle basically, the size changes every time with a bit of, with an offset, and that makes the circle grow. If I think this goes too fast, I make it a bit slower, and then you'll just see it go a bit slower. You can make it super psychedelic and make it 50, and then you really get a headache. Can be done as well. Let's not do headaches. Voila. So you can start playing with that, and that's how you create movement. That's all there is to it, in a sense. It's not more complex than that. It's not more. It's that. So let's do a couple of examples. Typically, I mentioned patterns. Lines are probably the simplest kind of patterns you can do. So here I have one line, one horizontal line, and vertical lines on the other thing. Pretty boring, pretty thing. But again, you can start playing with it. Maybe if I make it a bit, make it a bit like this. This is even more boring. Maybe if I do 4, what happens then? Yeah. Probably a bit too much for the morning. You can start playing. See the nice patterns. You could also put it under. You could put them under an angle, that they are a bit more interesting. I don't know. I think I did it randomly here. So again, you just start clicking and start seeing, and don't forget to do a print screen or save this picture if you really like it, because it will never come back in that form again because of the randomness. Voilà, so yeah. And again, you can play with the colors and so on. Yeah. A word about randomness. Sometimes randomness is nice or is cool. Sometimes it's a bit too much. In this case, I just assign random colors to these squares. And frankly, yeah, I mean, it illustrates the concept of randomness, but I don't think it's really interesting. It's a bit too much and a bit all over the place. That's why they have in P5, they have the Perlin noise. And Perlin noise is a function, it's a complex function with sinuses and blah, blah, blah. And you typically give it, you can give it variables. You can call the noise function with 1, 2, or 3 parameters. And one of the effects of that is that if you call the noise function with the same value, it will output the same output value. So there is consistency in there. And if you call the noise function twice with values that are close to each other, the output is also close to each other. So here I use that property to do grayscales. And you see, it's more interesting than completely random black and white and gray. But there is a bit of a flow in there. You can even you can even yeah, voila. So there's a bit of flow in there. You can even change that to be a bit more or a bit less. Here now there is a lot less fluctuation because you put the numbers in your input space closer together, or you make it more closer to a real random, and then you get this. Again, you can play with that depending on what kind of effect you want to create. Pardon. What kind of effect you want to create, you can play with that. Of course, you can put a bit more color in it as well, and then you just you try and you see what you like. Will you win a Nobel Prize of Art with this? I don't think so. Will you have fun for half an hour playing with this and impressing your friends? Oh, definitely yes. I don't know. Well, you could even use a similar technique to create procedural landscapes. Because what I do here is, instead of working with squares, I just work with the pixels, and I create I create a noise with noise gives me a color, and then I check if it's between that and that value, I paint it in as water. If it's between that and that value, I paint it in as sand or whatever, and you get something like this. And if you then change a bit here, wait a minute, I have to look in my notes. Frame count. Oh, this. And I comment out my no loop. Then you get something like this, where it starts scrolling. And I don't know who of you played 1942 on the arcades once. You know the game where you are on, in World War II, a little plane, and then the thing scrolls down. That's how you could build such a thing. And of course, if you, depending on how you play with your zoom and you can play with a couple of parameters. I have no idea what this will give me. Now it's a bit more complex. It's as if you're flying higher, or as if you're more, or if you're really close to the ground, and it's probably something like this. Oh, that's not what I expected. I think I messed up. What was the original? Yeah, that's better. So make it 1, for example. So now it feels like you're flying closer to the landscape. Again, nothing too spectacular, but this is on one hand some relatively simple rules, and you get nice effects, right? I also find it very interesting. I mean, I talked about sines and cosines. What if a teacher would come up with this kind of things, where it shows you, hey, the blue one is and now I have to be careful, the sine, the other one is the cosine, and probably otherwise around, doesn't matter. I mean, it's early for me as well. But now you see when it is positive, when it is negative, when it goes over I mean, this is a lot more visual, I find, than what I got in my textbooks like ginormous amounts of years ago. We know that we know the first formula, that's the unity circle, but what would happen with the second one? Yeah, then you get things like this. So if you here, it's not the sine and the cosine of an angle, but it's a bit of the angles are a bit different. So you get things like this. This is super nice to play with. Hola. Then you get something like this. It's like Celtic knots. Like sometimes it's an open figure, sometimes not. Sometimes it's relatively chaotic. Sometimes it's done. I mean, again, not world shocking, but amusing nevertheless. Let's just wait for it to finish. This one will probably be a closed one after a while. Yeah, voilà. Yeah. This one is an example where I use P5 on one hand, so I use the webcam. It has a webcam interface, and I use an AI model to detect my face, to detect basically my ears and get steam out of my ears. I had this on an exhibition in Halle where I live. It was a standalone exhibition, and there was at a certain point in time there were a mother and 2 of her smaller kids. They were in front of the camera, and the steam came out of the ears of the mother. Really, that was such fun. I mean, because it only detects one face. It's then one of the 3 faces was detected and got a steam, and it was the mother. That was perfect. Again, this is very accessible. This is perhaps 20. There's more code to get a steam effect than there is to detect the faces and the thing. So that's super easy. Like I said, P5GS. I'm really a big fan of it. I really encourage you also to look at the coding train. The website is nice. They have a YouTube channel, and I get a lot of my inspiration there. I myself write tutorials on nerdkunst.be. If I have some time, if I have some energy, then I upload a tutorial every now and then. But again, there's also music. I stumbled relatively recently on Strudel. I mean, P5 I know quite well. Strudel is more complex. I wish I was more into music theory than I am now. But this is also in the browser, and you can play this thing. So you can write these kind of things. So if anybody of you familiar with Sonic Pi, this is something it's a different syntax, but it's relatively similar, and it runs entirely in the browser. Where Sonic Pi you have to install and so on. I'll give you a quick intro on how to. Again, I'm not a. So this is the basic thing. You just play some notes. You have different sounds, pianos, drums, whatever. You get something like this. In this case, if you put your notes between brackets, they are played together. So if you listen carefully, the last part is two notes played together, and in the sound, because you have two sounds there, it's the first part. The first part is played by the piano, the other part is the guitar. I don't know if it's loud enough, but. So now, if you put it between these things, it chooses for each time. The first note is always played, and then the second takes otherwise the other one. Again, nothing fancy, and then you can. Again, I'm not capable of producing these things as just out of my head. I have a problem. It takes me an hour of thinking and songs and becoming half mad before I have it. But okay, why not? And then you get things like this. Well, this will not do anything, but if I start commenting this out. In the end, that was it for me for this presentation. I hope you get like the urge to start playing with P5 and stuff like that yourself. Any questions? Yeah. Okay. The song was Bronski Beat with Small Time Boy. Yeah. Well, it was an attempt to that.
And the second question is, I can imagine, at least with electronics, I have this situation where you have something, you tinker around, and you get kind of to the storefront demo, kind of it does all the colors, etc. And then you have to go a little further, and then you kind of make it your own. I was wondering for you, if you work on an artwork, like how long do you keep working on that one before you move on to the next one? And do you ever like revisit it, etc.? Do you have like some internal rules for it, or
that's a very interesting question. And like I said, I'm not so much an artist as I'm more an educator. I like these things to I get my kick out of presenting these things and getting other people enthusiastic about it. Not so much about making something truly unique. So yeah.
Do you have a feeling for when it starts to convey the point you're trying to make? Like, is it like a
like with anything, you can build upon it, and at a certain point in time, I probably lose my interest in that particular thing, and then you move on to the next. Yeah, voila. It's more about the experience of building it than the actual product for me. But okay.
Just a short and probably obvious question, but does the music thingy also has a random function?
Probably yes. It has multiple random functions. You can, yeah, it definitely has. And typically that is used, for example, to pitch up tones or down, or to filter things, low pass, high pass filters, to make the sound go a bit like this, or a bit like this, depending on how random you make it. Yeah.
Like I have a music machine, and I get a bit of randomness, but not too high because
White noise is not so nice to listen to.
It's really like a human pressing the keyboard, and not the same amplitude of the notes everywhere, every time.
Yeah.
So.
Thank you for your presentation. You got me enthusiastic to try this out, so
nice.
goal achieved.
Thanks.
I just had a question about, so you showed a few historical artists working with computers and generating this stuff. Are there a few modern artists which you find really inspirational at the moment we can point to?
I get most of my inspiration from people like the Code Train, who built these things, and who very much explain how the algorithms work and how they build up the whole thing from I have this idea in my head that it should do something, and then figure out. In the end, that's what gets me into this. So
Train is the point to go.
That's for me. If I mean, I'm on a very positive way, very jealous on the guy, how he does it.
All right, I'll check it out. Thanks.
Yeah. Any more questions? Yeah.
Questions?
There's one
All right.
gentleman over there.
Thank you for your presentation. I was wondering, have you also tinkered with doing these kind of things on a mobile phone?
No, I haven't.
Okay.
No, but I think since it's JavaScript, it will work. Although mobile phones are probably, I mean, writing a whole text on it. Yeah. Yeah, true.
I was wondering, as an educator, have you found any techniques that you thought at first would work, and then didn't end up working because it either got too busy or like too distracting or etc.?
What I still look for is I'm much more interested in the process of getting to something, and that's basically what I would like to convey to kids as well, that they try things out, learn from what's happening, and I'm not calling it mistakes. And that's somehow capturing that is what I'm looking for. That's also why I made this presentation so interactive, because I think it's that is the essence of it for me. Like tinkering, trying things out, changing these parameters, see what happens, be a bit surprised by the effect of it all.
And what generally works well in that regard? Like,
depends a bit on your audience, of course. What I see with the kids is that they don't have so much inspiration themselves, oftentimes. So it's either one or two things. It's either they have not too much inspiration, and then they need step-by-step things to start to build up, or they come up with an idea that is in feasibility similar to launching a starship, and then you have to break it down to a level that they can start working. I mean, we had guy, we should have a keyboard and blah, 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 blah. And before you know it, they build something that is They have an idea, but you cannot build that in one go, and then you have to slow them a bit down and take it steps without discouraging them that it can't be done.
Question 2.
Yeah.
Have you heard of cables.gl before?
No, never heard
it's
of it.
It's a node-based editor for real-time graphics.
Okay.
That's free and on the web, and might be something similar to kind of a blend between P5.js and a little bit of 3.js and Scratch in the sense that you're visually programming.
Okay.
So might also be something
I will
interesting
check
to
that out
try
later.
out. People are making demos in that.
And how is it called?
Cables.gl.
Cables.gl. Okay, I will have a look at it. Cool.
Okay.
Thanks. There's multiple questions.
Yeah, it's great. We had plenty of time.
Right. So, in the same vein as his question, actually, have you heard of Shader Toy?
No.
Okay. Well, there you go. Another recommendation. Shader Toy is different. It works with shader code. So instead of drawing shapes on a canvas, every pixel decides its own color.
Okay.
And it also has a sound mode where every sound sample determines its own amplitude from your shader code. So that's a different way of working that might be interesting to some.
Cool. There's one more.
All right.
At least one more question, and I think you had a question as well. So.
I was wondering if you know Max Cooper.
No.
He's an electronic music artist, and he also does very sick animations. And sometimes they look like they're like 2D generated art, and sometimes they're like very in a 3D kind of space. And I was wondering if you know what kind of tools he uses. But then you should look him up.
Yeah, I will have to. Again, I'm not an artist. I've said that before. That was my.
I have a question about. I mean, you're teaching kids.
Well, yeah, as a volunteer at college.
Yes, as a volunteer. So how do you think you could teach teachers?
Is that even possible? Yeah, voila.
I'm actually a primary school teacher, so I teach 9 to 12 years old, and I'm the resident nerd, obviously, but I also teach other teachers sometimes in the same way, basically. You present something, they can just repeat doing and then start tinkering, and then encourage them to just read the error messages if they are there, and try again, or look at the example again, and then they get into it quite easily. I do that teaching Haiti, by the way. That's teaching Python in a really gradual way. So that's a step-by-step thing. So teachers, after my workshop, they always say, oh, I can do this. So same thing. Okay, we'll talk after.
And thanks for your presentation.
Welcome.
I was wondering, because if I'm searching for tools to make art, I always come into P5 and also 3AS. Have you also worked with 3AS, and do you know like how they combine, or are they competitors?
As far as I know, 3JS is more for 3D things. So it's it has a different API, different things, but I think P5 is best in 2D. While with 3JS you have multiple. I have done some experiments with Matter.js, which is then more like a physics engine, and since it's all JavaScript, it's combinable. And
yeah, I see it getting combined a lot, but I wasn't sure like why you would need the two. But
well, for example, if you would want to make something where, let's say, round shapes fall down and then they roll away. So you need physics for that. There is no native physics engine in P5, but Matter, for example, is a physics engine. They also have a whole their own objects, and they can also render out images or the objects. But you could also just use the physics engine of Matter, and then the for the rendering and the objects have P5 do that. again, that depends on. There's no best way to do it. It just depends on what you know. I know P5 a bit, so for the objects I took that, and then for the physics engine I needed something. Then I took that one because it was also JavaScript and relatively easy to learn.
Cool, thanks.
Which tools did you use again for the Steam from the ears application? And does
Sorry,
it run offline?
Sorry, for?
Which tools did you use again for the Steam from the ears application that
Well,
you
that
did
was that was P5 still, and then ML5 I think it's called is the library that has models for face recognition, for pose recognition. So if you put like that, you get the coordinates of like 17 different points on your body. It has some other library, some other models as well, and they also run in the browser. So I combined P5 for access to the webcam and putting the view of the webcam and the Steam. The Steam, the clouds there. And then I used the ML5 model, PostNet I think it's called, that for determining where the position of the ears are, and then gluing the two together.
And you run all of that offline, so it's all.
That runs all on the
Okay, thank you.
It runs on a. I have this on a display, and it runs on a Raspberry Pi 5. It just runs. So on a Mac it runs, of course. It's a bit beefier.
Any other questions? I don't see any hands coming up. So please put all your hands up once again for Nick.
Thank you.